Hey guys, welcome back to A-Level Maths. We are gonna go through a revision differentiation from the first principles. Alright, so we're going to consider exam-style questions from Edexcel made by Myron, okay? If you need to refresh some knowledge, so make sure you watch the video about how to differentiate from first principles when I gave explanations for that. And also I derived this formula that you can see right here on the screen. So right now we're gonna go through medium hard questions, and in the end it's gonna be a challenging question. So get ready for this. Grab your pens, grab your notes, and let's get started. So you have the point Q with coordinates a and 10, and a is negative. It lies on the curve y equals x squared plus 1. So you need to find unknown a and show using differentiation from first principle that the gradient at point Q is negative 6. Okay, so first of all, let's try to find the coordinates for a, knowing that y coordinates of Q is 10 and it lies on the curve. So what it means that y equals 10 and you are eligible to plug into the equation of the function. So 10 will be equal to x squared plus 1. From where if you rearrange and take in the square root from both sides, you'll get plus minus 3. Because a is negative, in this case, x is going to be a, and we take only the negative value. Okay, so we found that a is negative 3, and this is x coordinates. And we need to show using differentiation from first principles that the gradient at point Q is negative 6. Okay, so we need to differentiate. In other words, we need to find y prime, or in other words, dy dx, okay, at the point Q. But first, before plugging coordinates, we need to find general expression for this. As you remember from the first principle, we need to make the difference on top and divide by h, and also taking the limit. So I'm taking the limit. H is very small, tiny horizontal step for x, and we making the difference. So we plug in x plus h instead of argument. So we plug in x plus h squared and still plus 1. This is the function y. So this is the function y from x plus h. And make sure you subtract y from x, which is normally x squared plus 1. So we subtract in x squared and we subtract 1, okay? So next we divide by h. Right now, we are going to rearrange a little bit, and 1 is cancelled here. So I will get the square of the difference of two squares, x plus h squared minus x squared. So I can rewrite as the following: x plus h minus x and times x plus h plus x. Okay, that how it works. Just I apply the formula: a squared minus b squared equals a minus b times a plus b. Okay, so we still divide by h, and we still taking the limit when h is very small. Okay, so x is cancelled here, so that's why we're left with y dash equals limit. H is tiny, and that's going to be h over h, and x plus x will give you 2x plus h. Okay, so h can be freely cancelled because I remind you that h is very close to 0, but h is not 0. So that's why you can freely cancel both h on top and in the bottom. And now we're left with 2x plus h. Then, right now, the transition, we use the limit. And in this case, we're saying that h is simply 0. So using the limit, we can freely put h instead of h 0. So that's why we were left with 2x. So that's going to be y prime derivative that is actually equal to the gradient, right? So this is general expression for derivative y dash from x equals 2x. Now what we're going to do, we need to plug the coordinates where we're looking for. So we're looking at the point Q, and that means coordinate a is going to be negative 3. So we plug in -3 right there instead of x, and we find the gradient at point Q, in other words, from -3, is going to be -6. Okay, so we prove that gradient is -6, and that's the final expression for the gradient. Okay, so let's go next. Hope it's pretty clear. Using the same principle, we need to find or prove that the gradient to the curve with the equation y equals 2x plus 1 plus 1 at point 0, 2 equals 4. Okay, so just saying that the gradient of the function at the point 0, so I'll just put a, okay, this is equal to, again, y prime. That means you do the same. So you're taking, by definition, what derivative is. So we're taking the limit when h is very small, 0, y x plus h, and you take away y from x and over h. Now we can plug those into the formula. X plus h new arguments, so that's why we take in the limit. H is very small, and we have the following fraction. So if we plug x plus h inside there, okay, we'll get 2 times x plus h. Be careful here. It's more about how accurate you in rearrangements. And you square this up, okay? And only on top of that you add 1. And then you take away y from x, which is normally your function. So you take away minus 2x plus 1 squared, and you take away 1. So be careful about how well you can simplify algebraic expressions. Okay, so it's done. And what we're going to do, just squeeze a little bit, okay? And we just simply need to do the following. So we need to rewrite y dash is equal to limit h is very small, and right now 1 is cancelled, and I'm again gonna use the formula for the square, for the difference of two squares. So I'm writing 2x plus h plus 1, and I take away, so right now I take away 2x and I take away 1, because those ones were cancelled. I just erased them. This one and this -1 is cancelled, and you left with minus. So okay, let's move next. This is the first bracket, and the next bracket is going to be 2x plus h plus 1, and you add this expression 2x plus 1. Okay, so over h. Next one. This is the limit, h is small, and on top of that we can expand brackets, so 2x plus 2h, so 1 will be cancelled, so I just erased those ones, and 2x with that 2x will be also cancelled, so I will left with just simply 2h. Okay, so I left with 2h from the first bracket, and I still multiplying here. I'll get 2x and 2x, 4x. On top of that, I'll adding 2h, and I'll add 2. Okay, and over h. Now I can freely cancel those h's. Remember, apply the same principle. And what I'm going to do right now, I'm just continue and say that the limit when h is close to 0, what I've got finally, I can factorize 2, and I'll get 4 times 2x plus h plus 1. Okay, now everything is ready to find the gradient at a given point. So right now we applying the limit, and finally we'll get, if we apply the limit, we'll get that derivative, we'll have the general expression. So 4 times 2x. Okay, I can expand brackets. So it's going to be 4 times 2x and 4 times 1 because h is simply 0. So h is 0 and we'll get 8x and plus 4. Now, because this is derivative, is the expression from x, right now we can freely put the coordinates x equals 0. So that's why we'll get 4. And that means that the gradient at the given point A, literally say we right now found the gradient at the point A, it equal to 4. Okay, so hope you understand that. And in the next video, we'll consider this question that's pretty hard and also challenging question. So make sure you understand those basics because next problems will have a bit harder level. So make sure you can do that before going to the next level. And don't forget to visit A-level classes. All right? At Zillion's A-level class. So we're doing together A-level stuff. So he has a bit different videos. Check them out. See you later.